EDX Core Pure complex numbers 2, the Eigen diagram, representing rotation and multiplication by I. Just a quick reminder about creating the imaginary axis. If we consider the complex number z equals 5, so that is a purely real number, z equals 5, if we multiply it by I, we get zi equals 5i. So this has resulted in a 90-degree rotation about the origin anti-clockwise. If we multiply by I again, we get 5i times I is 5i squared, which is of course minus 5. So this has resulted in another 90-degree anti-clockwise rotation. So it looks as though multiplying by I may always give a 90-degree anti-clockwise rotation. So we can put that to the test now by considering z equals 5 plus 2i this time, and we're going to multiply by I. So z I equals 5 plus 2i multiplied by I, which is 5i plus 2i squared. I squared is minus 1, so 2i squared is minus 2, and we would always put the real part first, followed by the imaginary part, 5i. So z times I is minus 2 plus 5i. And if we look on the Eigen diagram, z times I is indeed a 90-degree anti-clockwise rotation of z about the origin. If we let w equal minus 2 plus 5i and see what happens when we multiply by I. So we've got wi is minus 2 plus 5i multiplied by I. Expanding the brackets, we get minus 2i plus 5i squared. I squared is minus 1, so 5i squared would be minus 5, followed by the imaginary part, minus 2i. So there's w times I. So there's wi shown on the diagram, and this again has resulted in a 90-degree anti-clockwise rotation about the origin. In fact, multiplying by I will always give a 90-degree anti-clockwise rotation about the origin for any complex number w that you start with. So on this graph here we can see the complex number z1, which is currently 5 plus 2i, and if we look carefully we can see the complex number z2, which I've set at I. So I'm going to keep this complex number as I, and z1 times z2 is this green complex number here. So as I move the position of z1, and I'm going to keep multiplying it by I, just have a good look at the resulting vector complex number z1 times z2. And you can see no matter where I put z1, when I multiply by I always get a 90-degree anti-clockwise rotation. So that's a nice demonstration of what we've just been looking at. So that's the end of this section on complex numbers, looking at the Eigen diagram.